Hey guys, welcome back to another BTLO Replay. Today we have a beast of a lab, divorce code with hard difficulty from incident response category. Now this lab has been loved by many players, and yeah, kudos to them who managed to solve this fully. This lab covers a bunch of tools from different domains, like we have volatility for memory dump analysis, FTK imager for disk image analysis, IDA for looking at the binary files, debuggers like scdebug and s64debug, and many more tools. Now before we start solving this lab, be sure to follow us on X, LinkedIn, or join the Discord server to keep in touch with the BTLO community. Links are in the description box below. Let's quickly look at the scenario. One of our senior executives, Lord Admin Clickford III, demanded we give him a local admin account on his workstation, since he is something of a computer genius, as he likes to say. Regardless, he clicks and opens nearly everything he sees, and now we are becoming increasingly concerned about what else he might have done, especially as APD32 has been reported actively targeting our region. Since he is known for following best practices, the wizard has yet again compromised our environment. We have performed a disk and memory acquisition for the workstation and handed off the analysis task for this workstation to you to follow up on. With that being said, let's start diving to do the analysis. Question 1. According to the E01 file, who were the examiners performing the acquisition of the victim's workstation? For this, let's look at what tools do we have. So we have a bunch of tools, as already mentioned. Here we will be using FTK imager, and let's look at the artifacts. What all artifacts do we have? So we have RAM, which is our memory acquisition, and the hard disk acquisition, which is our disk image, and this is the E01, which is being referenced in the question. I have already opened this tool. Now once you open this tool, let's add the evidence. Click on file, add evidence item. Now the evidence which we have is an image file. We'll simply choose this option, click on next, and we'll choose the file. It's directly showing to me. Click on finish and let this load up. Now the image file is loaded up in the FTK imager. So what we need to do, like in order to look at the information, we can simply click on this plus sign, which is right over here, and you can see all the partitions are showing up here. But our question is asking who were the examiners for this case. Now if we scroll down, you see we have this field called examiner, and we have the name Jalma and Satek Astronomy, if I said the name correct. So simply copy this name. I'll just copy and I'll go to questions and let's paste and let's submit, and yeah, it is correct. Question 2. What is the name of the file that caused the initial infection, and from what URL was it downloaded? Now this question is giving us a hint. Specifically, the file is downloaded. That means if a user has downloaded the file from a URL, so probably it should be residing in the downloads folder. So let's go over here. We have to expand this. Let me see if this is the one. So this can take a bit of time, to scan all the files and to properly show you the result. Okay, now we have the result. So we have the tree, root. Let's go into the user, and by the way, this root is what local disk C in our Windows system. We have the admin user, and let's go into downloads folder. Over here we see a chrome setup.exe and a file sample devos agreement clause.zip, and it seems to contain, if I can click on this seems to be some sort of JavaScript file based on the icon, if I guess it correctly. So we know the name of the file, but now we need to know from where it was downloaded, because the question asking the URL from which it was downloaded. Now over here the question comes, where is the history file located? We have a hint that it is probably going to be for Chrome history. So for that, you can directly search online for the Chrome history artifact. I'll directly let you know. So we have to go in app data, local, and then we have to go Google, Chrome, user data, default, and in here we should have a file called history. Yep, there we go. Click on this file, right click, export files, and let me just export it directly to the desktop. Okay, and if you can see, we can see that this is an SQLite format file, and we also have a tool in which we can view the SQL file. We'll simply open this DB browser, let this load up. Now once the tool is open, we will open the database. Let's go into desktop. I'll choose all files, history, and there we go. Here we have what we are seeing on the screen is the schema of the table, and we want to browse the data. Simply click on browse data, and what data or which table we need to look, we will go into downloads. And over here, if we see, we can see that this is the file which was downloaded. And if we scroll, you can ignore this error, and if we scroll to the end, we should be seeing URL. Yep, there we go. Click on this, and here is the URL from which it was downloaded. You can just copy this, copy, and the question is asking for file and then the page. So I'll simply copy this file name as well, copy, paste, and make sure that it is in exact format, submit, and yeah, it is correct as well. Question 3, specify the resource development and the initial access techniques used by the adversary to compromise the victim. Hint, we want the technique, not the sub-technique. Now, we just saw that the file was downloaded from a specific URL, and the biggest red flag was it is hosted or it is using HTTP as a protocol, which is sort of suspicious. And from this, we can at least infer that the adversary or the attacker would have bought a virtual private server, VPS, and purchased a domain as well. Now, if we go into MITRE framework, in the resource development, we have almost like 8 different techniques. One of them is acquire infrastructure. If we go into this, we see what all different sub techniques do we have. So in this, we see attacker can buy a domain, DNS server, VPS, and all those stuff. Since we have to just give out the technique, we can simply use this one, not this, my bad, this one, T1583. Let's go back, T1583, and the initial access technique. So in the initial access technique, we have a technique called drive-by compromise. And if you go through this, you will understand that this basically means any website or any domain which attacker is having access to, and that specific website is being browsed by the user like normal, and using which the attacker has like hosted some file or getting the access into the system. Hence, this is the one which best fits in our scenario, and the ID is T1189. We'll type T1189, submit, and yeah, it is correct. Question 4, what is the MFT record number for the downloaded file in hex? For this, let's come back to FTK Major, and if we click on this file and we look here in the properties section, and if we scroll, we should have an entry with MFT record number. Here it is, and here we have a number which is in decimal 44344, and the question is asking for hex. So let's just go online and just search for any decimal to hex converter, And over here, let's give 44344 convert, and we have our hex, which is AD38. And the question is asking it should start with 0x AD38, submit, and yeah, it is correct. Question 5, when the victim executed the file mentioned on the previous question, which is the first stage downloader, it injected some shellcode. This shellcode downloaded a second stage of binary to some directory and ensured persistence. From which website did the downloader get the second stage of binary, and where did it downloaded it to? Hint, make sure to remove any double skip character. For instance, if you get this, the accepted answer is this. And this is, whoa, worth 10 points. That means we are increasing the bar. Okay, not to worry. So we know that this particular file is when it is getting executed, or specifically this JavaScript file, it is downloading some sort of additional binary. So let's just right click on this, because this is what we are going to analyze. Save it on desktop, and let me minimize this. Now in the desktop, let's right click on this and extract over here, 7-zip, extract to this. Sweet. Now let's right click on this file which we just got and added this in Notepad++. Let me see if I can zoom this in. Okay, now once you've opened the file in Notepad++, so what we can do, we can just simply go on view, and we should choose word wrap. Okay, now here we see that there are a lot of keywords directly right off the bat. We can see run, wscript shell, and there are some random like functions or addresses, what you can see over here. And then the main part is this obfuscated base64 string, which is obviously getting executed using PowerShell along with some of the parameters like execution policy bypass. So let's start analyzing this. Let's deobfuscate this particular string. Right click, copy, and let's go into CyberChef. I have already opened this up, and just in case this is present or given to us, it is desktop, tools, and here we have CyberChef right over here. Now once you've opened this up, let's paste this, Control V, and from base64. Sweet. We do see some sort of like some senseful or some meaningful strings, but we do have this dot. Now if you don't know this, let's try to replace them. Okay, let's just take this route. Let's hit dot, and let's choose a single string. And yeah, you can see, like, even though we are searching for dot as an individual character and try to replace it with nothing, it's not working. And the reason behind that is, I'll explain you. If you just do 2 hex, now if you add 2 hex, you see we have 0 after every character, which is the null byte. So what we can do, let me just remove them, and this as well. And over here, simply search null byte, and you will get this option, remove null byte. Choose this, and here we go. We have decoded this particular base64 into some meaningful, I'll say, code. Now in this, if I can just zoom in, let me try. Yep. Now in this, we do have again another base64 string, which is like from base64 string, it is getting, here it says gzip stream. So possibly what we can understand is this particular base64 will get decoded, and whatever the data is, it will then get into a gzip file. That means this is, in short, a gzip file in base64 format. Let's copy this and paste it here. Okay, you don't worry, this is obvious to see. Now just to confirm if we indeed have a gzip file, so CyberShell have this recipe for detecting file type, and it does say that this particular data which is coming from base64 decoding is exactly gzip. I will stop this one, make sure that only base64 data is piped out. I will save this and I'll rename this as from js.gz. I will save this. Okay, let's go to downloads folder. Let me just refresh it. Yep, it is there. Right click on this, 7-zip, extract here, and we get this file. Again, let's right click on this, edit with Notepad++ to see what do we have. And great, we do have what seems like to be a shellcode. You can see this byte array, it indeed looks like a shellcode. Let's just copy this, go back to CyberChef. Let me just remove all of this as well, paste this here, and let me try to from hex. We do see some garbage data, but we also have some meaningful substrings like Microsoft, which obviously meant Microsoft, software, current, Defender, Windows, and yeah, HTTPS. So this means that this is some sort of shellcode itself. Let's just save this to file. And here is the fun part, which will be beginning in some moment. Let's open PowerShell or command prompt, whichever you prefer. I prefer PowerShell. Now I'll go to scdebug folder and I'll run directly scdebug -f. We need to provide the file. It is in users BTLO downloads, and it was like download.dat. Hit enter, and yep, we do see nothing. Now technically this should have been the route, but let's just assume that there is somewhat like garbage value or data, because of which this tool scdebug.exe is not properly running. You can also try to pass additional parameters like -s, which means for step, like how many steps should it execute. Let's give it this much, and still we have nothing. Now there is a dirty hack to do this. What you can simply just copy this part and see what information do we have, or like what meaningful strings do we have. So I will go directly to users BTLO downloads, and I'll do strings on this particular file, strings download.dat. Hit enter, and from this we need to pick out the respective, I'll say, characters, and join them together so that we have something meaningful. And a pro tip, always start from the bottom to top. So you see we have CPROGR, and then we have PTAT, something which is garbage, and we see after R we have AM data, like program data. Then we have U, PH. So what you can see over here is that PH is added, and we can just ignore this. Program data /USO shared, then again /certutil.exe. There we go. We have something like a directory in which the file is getting saved, and what we are looking for, if we just glance at the question back, it is asking for from which website it was downloaded and where did it download it to. Now over here we have HTTPS, which obviously looks like a website, ://dfir.pt/ let's ignore this ph, JALMASE, ignore this, tec.btl. this does sound like a website. So let me do one thing. Let me just grab all these meaningful strings, join them together, and let's look at finally once we have something specifically carved out. So after finding all the meaningful keywords and strings and joining them together, here is what we get finally. We get a location where a file is present like certutorial.exe, and we have a name, Windows Defender Certificate Update. Then we have a registry location, and if we look at them, can be understood that this particular is a name or the key which is used in this particular registry location. Then we have a URL and a few API calls, exit process, red set key value. Let me just check if it is the same. Exit process, yep, red set key value, and I just missed the A, you can see over here. Then we have winexec URL download to file A, and in this also there will be A. So this is how you can just find all the information from this, rather than decoding the shellcode using scdebug. But yeah, in case if you are one of those who solve this lab successfully and you use scdebug to decode the shellcode, then do let us know in the comments how you do it. Now coming back to the question was asking from where this file was downloaded. So let's use this. This is the website which we got. Website and the file where it will be downloaded to. So it seems that this is the only location which we get. Paste, submit, and yeah, it is correct. Question 6. The shellcode mentioned in the previous question makes use of several Windows libraries and several functions inside those libraries. For instance, it uses a lot of functions such as get proc address from kernel32 library. Which functions are used by the shellcode that do not belong to kernel32 library? List them in an alphabetical order. Hint, it is two functions. That means we have to find two functions. And okay, so if we look at the strings output, we have get proc address, and we can just directly remove it because it is already mentioned. Now interestingly, we already found these two functions like URL download to file A, red set key value A, which upon looking online does not belong to kernel32 library. So let's give this a go. And another reason, because they are directly related to downloading this particular file and then setting up the registry value over here. So let's just enter this, and we have to mention this in the alphabetical order. So reg set key value A, comma URL download to file A, submit, and yeah, it is correct. Question 7. The shellcode mentioned on the previous question also ensures persistence in accordance with MITRE ATT&CK technique ID. This, what is the registry key value added for the persistence mechanism? Hint, consider the following command line to define what is a key. Okay, now initially when we were solving the question 5, we looked into these two strings. You can correlate that this can be the key, okay, which is getting saved inside this particular registry. Let me just copy this, paste it here, and submit, and yeah, it is correct as well. Question 8. The first stage downloader from the previous questions pulls down a MSF Venom payload that has been ZORed. What is the ZOR key to decrypt the shellcode in hex, and in which PE file section is the key stored in? Okay, so for this, first of all, let's grab the exe file, and now we know the location from the previous question. It will be in C, program data, USO shared, and here we have certutorial.exe. Right click on this, export files. Let's save this on desktop. Okay, perfect. Now we have different options from here to look into this question. Like first we can directly open PE Studio, check what all sections do we have and all those things. But let's take the direct jump, and let's open IDA, because that is where we can see the content, what are the instructions, and there as well we can see the sections of the file also. Let's add the file, desktop, certitle.exe. Okay, okay, cool. So now we have the disassembly in the graph over here. Let me just try to increase the font to 16. Apply. Okay, much better. So what it looks like, if we see, we have a call to main, then we have something called super code, super secret, and then this seems to be a loop. My bad. Yep, loop, which is joining over here. So that means this seems to be a loop, and what I can understand is this should be the counter. Let's see if there is any addition to this, if this is a loop. And the reason I'm saying this is a loop, because the tail of this particular block is joining to the initial one. And yeah, indeed this is adding 1 to this particular variable. So I'll just rename this. I'll rename this as counter. So this is the counter. It is getting compared with this length. Like this is the length. Like if we convert this particular hexadecimal character 227 into decimal, we will get the exact number that many times this particular loop will execute. Then we have the super code, super secret, and then we have XOR. Now the question is asking that or the question is specifying something is getting XORed. So here we have the XOR which we are interested in. So ECX is getting XORed with EAX. So let's see from where the ECX is coming. ECX is coming from here, which is byte pointer to RAX plus RDX. RDX is something which is present in super code. We click on this. This seems to be a very long hexadecimal byte array. Yup. So this can be like thought that this is some another code which is present inside this particular address, and it is getting XORed. So ECX is the super code, and EAX is coming from RDX plus RAX. RAX is coming up from here, super secret, and this seems to be a short key because this is like just what 4 bytes. So that means this is our XOR key, okay, and this is XORing the initial code or initial bytes which are present over here. So let's click on this and let's use this as the answer. Let's go down, and we have to use 0x and BA, D6, E7, EC, and it is also asking for the section. So right over here we can see that this particular entry is present in .r data. So .r data, hit enter, and yep, it is correct. Question 9. What are the first 8 bytes of the decoded MSF Venom payload shellcode? So for this, now we know that this is the XOR key, and what we saw previously in the super code is the MSF Venom shellcode. And the question is asking for the first 8 decoded bytes. So let's open CyberChef. Okay, now since it is only asking for first 8, so I'm not very much bothered about dumping all this data and then selecting the first 8. I can directly copy from here. Now make sure you copy all this. I'll just copy this at my end. Now we have the first 8 bytes over here. Now let's do from hex. Let's check this, and now we have to XOR the content. So XOR, and we know that it was BA. Let me just check this once again. Okay, and then let's convert it back to hex, and this is what we get after we XOR the shellcode bytes, and this is the first 8 decoded bytes that we get. Just add this. This is what the final answer should be. Copy over here, let's paste this, submit, and yeah, it is indeed correct. Question 10. We know that the shellcode generated by MSF Venom that has been XOR encrypted by the adversary also has a built-in XOR encryption mechanism. What is the XOR key that is protecting the reverse shell code? Hint, the XOR key inside the shellcode itself. Okay, now we are at the point when we have to decrypt or XOR the whole encrypted shellcode. So what we can do, there are total 2 ways of doing this, or maybe more depending upon individual's perspective. But from the tool side, it can be either done using IDA, or it can be done using x64 or x32 debug based upon the architecture. Now since we are in IDA, so let's just do it right away with this only. So we have super code, we have all the content. Let's go to the hex view, and here we see we have whole hex string, which is the encrypted or XORed encrypted shellcode. I can simply copy this like this, right click, and save to file. I'll name this like hexed, or better if I type XORed shellcode.txt. Save. Okay, let's go to CyberChef. Now let's use CyberChef to again XOR decrypt the whole shellcode. Let's open the file as input. We have XORed shellcode over here, and since this is already the decrypted format or not present in the hex byte, we do not have to decode it from hex. We can directly just XOR this right away, and let me just grab the key. Now we have XORed using this key. Next step is to let's convert it back to hex. Okay, we see the initial bytes what we got earlier in the previous question, 4831C9. Now there is a trick. If you already knew this, let me know in the comments as well. We can directly convert this hex into its respective disassembly. If you type disassemble or disassembly, whatever you want to feel like, and just use this recipe, and here we get the content or the disassembly itself. Let me just zoom in. Yep, seems perfect. So here we see we have some content, XOR RCX, then we have some instruction, load, move this content into RBX, then we XOR something with RBX. Now this XOR is simply to flush out the RCX register, and this XOR, like comparatively compared from this means, or this XOR actually performs some sort of XOR operation upon 2 different characters, and it is XORing this particular pointer or whatever is present at this location with RBX, and RBX contains this particular string or hex bytes. And with this we can say that this can be the XOR key which is decoding the MSF Venom shellcode. Let's just copy this, go to question, and is asking in format 0x, paste this, submit, and yep, it is correct. In this, we extracted the shell code from IDA. Let's just close this, and let me show you how we can find the same in x64 debug. And for information, this particular file certutil.exe is a 64-bit architecture file, so we will be using x64 debug. Now over here, we have already started or opened the file in this x64 debug, and what we need to do, we need to go at memory map, and we know that our data is present in .r data section. You can click on this just to verify, double click on this, and here you see we have F2E7 2E. This is the Zord encrypted shellcode. Let's go back to memory map, right click on this, R data, dump memory to file, and you can just give this a name, shellcode, save, and this will again give you the Zord encrypted shellcode. Let's try to open this, and here you go, we again get this particular entry. So different tools, different method, but eventually leading to the same. Question 11. When executed, the downloaded second stage beacons out to a command and control C2 server. What is the source port of the outbound communication, the destination IP, the destination port, and the destination domain name for the traffic? So for this, FTK imager or the disk imager may not help us, because that is something which is referring to disk. But what may help us is the RAM image or the memory image, which contains the volatile data, which is the activity that was present at that time, and the connection which the question is referring to is something which is live or which would have been live at that point of time when the image acquisition was happening. So let's open the PowerShell or command prompt, go to volatility, and we have in terms of artifacts, if we go on desktop artifacts, we have RAM, and this is the dump file, this is the memory dump which is given to us. Now the question comes, how to find the network activity using volatility when a memory image is given. So for that, search online for volatility cheat sheet, as I did, and this is the best one which I prefer, because this particular resource, book.hacktricks.xyz, contains all the required information, specifically when it comes to volatility. Individuals may have different perspectives. Now here, if I scroll, I see option for network, and for volatility 3 we have to use this particular syntax, vol.py, provide the file, and then we have to use windows.netscan.netscan. So /vol.py -f, then we have to give the file name, artifacts, RAM, and the dump file, and then we have to provide windows.netscan.netscan. Hit enter. Now the initial profiling is done, and it will then scan for this particular parameter which we have passed, which is for network related information. So we already see some fields like offset protocol, local address port, foreign address port, state, PID, owner, and when this connection was created. So it will scan the whole memory image and it will provide us the information. This step can take a couple of minutes. Now how we will identify which particular entry is the one we are looking for, because there can be n number of entries or n number of connections. It can be legit. Now based on the IP address, how can we identify it? Now in the previous questions we found one exe, or the question itself gives the hint that when the second stager was executed, which is the certutil.exe, that created the beacon. So now what we will do, in this data we will search for certutil.exe, and right off the bat I see it over here, certutil.exe. That means this connection is the one we are looking for. So we have source IP, source port, destination IP, destination port, and like I said, certutil was used to establish connection. Now the question is asking for source port. So source port is 55076. The destination IP 134.213.138.55. Destination port 443, and destination domain name. Now we do not have domain name, so let's just search it, and the best place which I prefer is generally VirusTotal or abuse IPDB. So let's just copy the IP. I have already pasted on the VirusTotal, and you can see right off the bat it gives us 0 detection. So just a pro tip, never be fully reliable on VirusTotal in terms of detection, because you see this particular IP address was resulting in a malicious connection. Still we are seeing 0 hits. Also, this can be same with any malicious file or any other entity which is indeed malicious, but it will show you 0 hit. Now on the contrary, if you see some malicious hit, like okay, 10 antivirus engine detected this particular entity or object as malicious, it is good for you. If it is not, then just make sure you take an extra step to investigate it further, to be fully, or like to be double sure that it is indeed a legit entry. Now coming back to the question, it is asking the domain name. So let's go into details. Here we do not have anything. Let's look into its past relation, and we see some domains which are not related altogether themselves. Let's expand this. Okay, you do see a bunch of them, and we see that certutil was communicating file for this. Let's see certificate history. This particular entry, like snafu.bofh.pt, seems to be like something off, because others are sandbox dfi.pt, btable.com, hosting something something. So these two, sandbox.dfi.pt and this particular snafu.bofh.pt, seems to be like suspicious. So let's just try them out. So you can copy and paste it here, submit, and yeah, it is indeed correct. Now what if this was not correct? We would have given the other entry a shot, like sandbox.dfi.pt, and something from them which seems to be off. Question 12. The second stage after beaconing out migrates itself to a different process. What is the process name and its PID? Now this question might sound a bit trivial to solve that. Okay, how can we find all the entries? Should we look for all the process list? Should we look for process tree? Obviously we can, but there is one additional I'll say plugin in volatility which helps us to find any malicious entry in terms of process, and that is, if we go back here and we see malware, this is the one which we can use, windows malfind.malfind. So again, the one malfind.malfind, hit enter. Again, this can take a couple of minutes. Now we have the data available with us. Let's just look if something stands out. Okay, everything seems good. Okay, this one seems a bit odd. MZ, MZ, which is the initial bytes of a PE file, and it also starts with 4D5A. This means that in any section of this particular process, explorer.exe, with this PID, an injection would have been done. Hence, we are seeing an exe or a PE file inside this process. Let's see if there is any other useful information which we can find. None apart from that. So let's just use this explorer.exe. So let's just use this process name is explorer.exe, comma 3804. Submit, and yep, it is correct. Question 13. The adversary downloaded an additional tool from a website using certutil somewhere inside C program data. Knowing that certutil leaves specific artifacts in specific directories, identify the certutil artifact location for the downloaded file. Copy of the downloaded file, where was the file downloaded to, and from where it was downloaded from. So for this we can directly go online and search for certutil artifacts, and the first URL that came from me was this thingdfir.com. Over here it gives us information that certutil keeps a cache stored in the in a few of the location, possibly more. Here are the location, okay, like user profile, app data, local flow, crypt, net, URL cache. And if we scroll down, here is what it should look like, something with like the file name starting with the hash. So let's go into FTK Major, because there only we have our disk image. So user profile, app data, local low. So let's go app this, root, user profile, app data, local low, Microsoft, crypt, net, URL cache. We have the metadata and the content. Okay, let's go into metadata. We do see a lot of hash files as expected. We can click on each of them. Everything seems sort of normal. Digital certificates, same here, same here. This one seems to be a bit odd. dfi.pt slash nope.btl. Now the question also tells us that the file was downloaded using certutil and was placed inside C program data. So let's just check that as well. C program data, if this is the file, yep, nope.exe, this is the one which we just found over here. So we have the URL from where this was downloaded, and we have the location, the program data, and we have the file over here. So right now I think we have all the three requirements, all the things which are asked in the question. First is the certutil artifact location, and the location is inside metadata over here. This is the name. Now this is the metadata, the content will be over here. Okay, then where was the file downloaded to? Okay, the location in which the file was saved, C slash program data, and the file name n0p3.exe, because this is already mentioned in the question itself, C program data, and upon looking we found the file present in the same location itself, and the URL from which it was downloaded, it will be find, or it will be present in this metadata. So we have HTTPS, let's just go at the end, https://dfir.pt/no or n0p3.btl. Yup, hit enter, And indeed, this is correct. Question 14. The file mentioned on the previous question is packed with BTL packer. The packer appears to be a well-known packer. However, it has been manipulated so that it evades detection. What's the original packer name? That is the one that was changed in order to create BTL. Sweet. So first thing first, let's export this particular file. Let's save it on desktop. Now to look into the packer part, we have to look into the sections, and for this we can use a tool called PE Studio, which is also given to us. Simply double click on PE Studio, open our file. Our file is on desktop. Nope. And right off the bat we see that signature contains a entry called UPX, which is a well-known packer. So we'll wait for sections. Now the question says the name was changed, but let's go back. Yep, it was manipulated to evade the detection. So we should see like sections related to UPX0, UPX1, UPX2, something like that. So let's just wait. But as of now, we know that the answer is UPX. So let's just directly enter that UPX, submit, and it is correct. But yeah, we can wait for this whole file to get fully processed in the PE Studio, and then let's see the sections. Okay, the sections seems to be populated. Let's click on this, and yeah, we do see BTL0, BTL1, BTL2, and this is similar to the original packer UPX signature, like UPX0, UPX1, UPX2. That means UPX, which is the correct answer. We verified using the sections as well. Question 15. Let's unpack this file. What is the original entry point, which is OEP, for the unpacked payload? Hint, remove the leading zeros from the answer. For instance, if the OEP was this, the answer would be this instead of this. Sweet. So we have our file which seems to be packed nope.exe. So first let's look into IDA. What do we have in this? We'll open this file. Okay, ignore all the messages. Now for this to unpack, we have to take a step back and see how the unpacking works. So we can directly look into the algorithm, but it is way out of the boundary of this question. And in general life as well, whenever we are encountering any sort of packed sample, instead of looking into the algorithm, we try to find ways to get a hold of the unpacked sample in the memory. Now this is the graph. We can just expand this as well. Let's expand this. Now here we have to see if there is any jump or any failed event. So let's look at it, which should be probably at the end. Yep, there we go. So this is the jump which is going somewhere in a total different memory location. You can see all the jumps over here are having the address starting with 68, whereas the jump which we are taking in this is for the address starts with 4373. That means all these instructions or the blocks which are above this particular block are doing the unpacking, and after unpacking it is moving the or transferring the execution to this particular address. So you can understand that this is the address where our unpacked sample will be loaded. Just to verify this, let's keep a note of this particular address. Let's open x32 debug, and in this let's open our file. Now this is the packed file, and if we see in the memory map, we are currently in this location, which is the BTL1 section. And once the system or the program is unpacked, the original malware is unpacked, it should go in this section, which is BTL0, and its address starts with 4 as seen in the IDA. So let's do one thing. Let's put a breakpoint at this particular address to see if we get something over there. So let's just do BP 437300, enter, and breakpoint is set. As you can see, you can also verify the same over here, and that's breakpoint 1. Let's do one more thing. Options, general, line prefix. Okay, sweet. So this is the location which is the starting, or which should be the starting of the unpacked sample, and this is where the address resides. Okay, it is inside the BTL1 section, as we saw, and the address of this instruction is 6884A4. So let's just set a breakpoint over there as well. Breakpoint 6884A4. Breakpoint is set, and you can see we have this jump instruction, which is an unconditional jump. Let's start the instruction, execution, and we hit our first breakpoint. Now at this stage, what we can understand that is the execution is completed, and this is the stage when the flow of the execution will be transferred to the unpacked sample. So let's just take a single step into, and you see this is where the next breakpoint is. This is where the file or the unpacked file should start. So let's verify this. Go to Scylla or Scylla, whatever you want to call it. Now this is the address which it automatically took. Now just to verify if this is the actual original entry point, let's click on IAT auto search. Now remember, this is the turning point. If you click on yes, you will get some answer which will seem legit. If you click on OK, get import, you will see that yeah, it is successfully showing you the output. But there is a key difference between a packed sample and the unpacked sample. The unpacked sample will always have more libraries, more API calls. Now let me show you again by repeating this step. IAT auto search. This time instead of yes, I will choose no. Okay, and you see there seems to be a difference. Click on OK, and I click on get import. You see the number of imports or the libraries or the DLLs have increased from 1 to 5, and the total imports are now 35. Now how you can identify that? You see using advanced, we were getting two options, like result of advanced and normal search is different. Let me just cancel this. So advanced search says that it found 60 entries, and this is what the addresses are. But the normal one, the one which we took, or the address which we took, we gave, based on that it found this. So let's just dump the file, click on save, and just for the formality, choose the dumped file again and fix the dump. So far so good. That means for our this question 15, the answer should be this address, but we have to remove the trailing 0. So 4x 437300. Submit, and yeah, it is correct. Question 16, how many import libraries, DLLs, and how many APIs within those library functions are used by the final payload once it has been unpacked? And hint is, this would be the same information that would be present on the unpacked files IAT, which is import address table. Now right off the bat, here only we can see that there are total 5 DLLs and 35 imports. So let's just type 5,35. But before submitting, let's also look at what the tool has to say. Specifically, if I talk about tool, the tool I'm referring to is P Studio. Let's click on this, click close IDA as well, open the file and choose this. Also, you can see the difference between the packed and the unpacked sample. The packed sample was only 803 kilobytes and the unpacked is of roughly 2600 kilobytes. Open this sample. Now earlier for us, we were getting a signature which was having a UPX and a link pointing to it, but this time we do not have any signature. So let's submit the answer and see if it is correct or not. And yeah, it is indeed correct, and that was it. So this was a pretty I'll say rough lab which allowed you, or challenged you to go through different types of artifacts, from memory dump to disk image to reverse engineer or to manually unpack any sample. This was a pretty good solid lab, and this was a big reason why it was loved by many of the individuals. Thanks for watching. Be sure to like and subscribe to never miss a video. In the meantime, remember to join us on Discord and tune in every Friday at 6 p.m. BST for BTLO Replay. Thanks everyone. See you next time.